Hello guys, welcome back. I hope you're all doing great. Today we'll be solving a coding question from the HackerRank website. If you don't know about this website, do check the link in the description. It's a very good place to start solving coding puzzles. They offer a wide range of coding languages to solve with. They also have a bunch of other features in their site, so do go check them out. Today we'll be solving the Kangaroo problem. As you can see here, they have given the question with sample inputs and expected outputs, the test cases. Everything else you need to know is given here. I'm not going to read the entire question. Rather, I'll explain what the question is asking us to do, and then I'll explain the logic I used to solve the problem. And then finally, I'll implement the solution in C and show you guys the final code. So there are two kangaroos, and you are given these four values. The starting position of the first kangaroo, the velocity of the first kangaroo, or the amount of jumps the first kangaroo makes at a time, the starting position of the second kangaroo, and the velocity of the second kangaroo. It is also given that the kangaroos only jump in one and the same direction, and they keep jumping till infinity. So your job is to find out whether or not the kangaroos will meet at a certain point after they start jumping. If they do meet, you'll have to return a yes, and if they don't meet, you'll have to return a no. So that is all for the question part. If it was the question that you guys had trouble with, then pause the video and try to solve it on your own. If not, then let's move on to the logic part. Let's take a look at the values we are given. We are given the starting positions of both kangaroos. We are also given the number of spaces each kangaroo jumps. Let's look at a sample test case given by the website. If you enter 0, 3, 4, and 2, where 0 is starting position of kangaroo 1, 3 is the velocity of kangaroo 1, 4 is the starting position of kangaroo 2, and 2 is the velocity of kangaroo 2, then the output is a yes, which means that the kangaroos do meet. Let's try to visualize this test case. Kangaroo 1 starts at position 0 and keeps jumping 3 spaces at a time till infinity. So it will start at 0, then we'll go to position 3, then we'll go to position 6, then 9, and 12, and so on. So if you write that down, what you notice is that you get a series, 0, 3, 6, 9, 12, till infinity. Let's take a look at Kangaroo 2. Kangaroo 2 starts at position 4 and jumps 2 spaces from there on. So if you write that down in the form of a series, you get this, 4, 6, 8, 10, 12, till infinity. As you can see here, both the series have a common term, which is 12. In other words, this means that the kangaroos meet after 4 jumps. If you have some memory of the maths you learned in high school, then you'll probably remember the chapter called Arithmetic Progression. If you're a person who hates maths or wants nothing to do with it, don't worry. Even though arithmetic progression sounds very difficult, all we will be doing here is basic addition and division. So please do bear with me till the end. So if you guys know how AP or arithmetic progression works, then you can skip to the timestamp given in the screen. If you guys want to know how AP works, then keep watching. So in an AP, you have the first term, so I'm going to call it X, and you have something called the common difference. I'll call it V. And to find the nth term of the progression, which is some term in the future, all you have to do is use this formula, X plus V multiplied by N minus 1. Or X plus Vn minus V if you expand the brackets. So how are we going to use this formula for this problem? Let's take our first kangaroo. The starting position is at 0. So what we do here is we put X equal to 0. Next, the velocity of kangaroo 1 is 3, so we put V is equal to 3. Filling this in our formula, we get 0 plus 3n minus 3, or 3n minus 3. And this is our formula for the AP of Kangaroo 1. If I wanted to find the fifth term in this AP, then all I'd have to do is substitute 5 in the place of n. So we get 3 times 5 minus 3, which is 15 minus 3, which is 12. And sure enough, if we check our previous number series we wrote, there sure is a 12 as the fifth element or fifth term. Let's make a formula for our second AP for Kangaroo 2. X is equal to 4, which is the first term or the starting position, and V is equal to 2, which is the velocity of Kangaroo 2. So we get 4 plus 2n minus 2, which is 2 plus 2n. Let's see what happens if we check for the fifth term. So putting n is equal to 5, we get 2 plus 2 into 5, which is 2 plus 10, which is 12. So the fifth term in Kangaroo 2's AP is also 12. So now you probably understand why in the sample test case, they have given the program output as a yes. It's because both the APs have a common term, which is a fifth term. So if we derive a formula which checks if two APs have a common nth term, then we have solved our problem. And that's what we're going to do next. Let's take the general equations of our two APs. x1 plus v1 multiplied by n minus v1, and x2 plus v2 multiplied by n minus v2. Let's equate both equations so we get a formula for n, as that's what we want to know. So x1 plus v1 multiplied by n minus v1 is equal to x2 plus v2 multiplied by n minus v2. So after a few rearranging, we just want n on one side and everything else on the other. We get n is equal to x1 minus x2 plus v2 minus v1 divided by v2 minus v1. Let's see if this formula works. I'm going to put x1 is equal to 0, v1 is equal to 3, x2 is equal to 4, and v2 is equal to 2 from our test case. So we get n is equal to 0 minus 4 plus 2 minus 3 divided by 2 minus 3. And we get n is equal to minus 5 by minus 1, which is equal to 5 by 1, which is equal to 5. And as you can see, this means that n is equal to 5. This means that both the APs have a common term at n is equal to 5. In other words, this means that the kangaroos will meet. Let's take a look at another test case in which the kangaroos fail to meet, or a sample test case where a no is returned. Let's see the example given by the website. 0253. x1 is equal to 0, v1 is equal to 2, x2 is equal to 5, and v2 is equal to 3. On substituting this in our equation, we get that n is equal to negative 4, which is not possible, as n can never take a negative value. And because of this, we can confirm that the kangaroos will never meet, and hence a no is returned. N should only take positive integer values. This means that floating point values are also not allowed. One final point you will need to also remember is that v1 and v2 should never be equal. If this happens, then we will get a division by 0, which will cause a math error. So let's sum up everything in the logic part so we can move on to the implementation. N should not be negative. N should not hold any fractional or decimal values. v1 and v2 should never be equal. And n, finally, is equal to x1 minus x2 plus v2 minus v1 whole divided by v2 minus v1. If you think you've figured out the code, pause the video, or you can even close the video now and go ahead and solve the question on your own. If you still wish to see the implementation part in C, well then, let's start. So first of all, what I did was copy the code from the editor given in the website to the code editor I usually use, which is gedit. If you want to edit your code in the editor provided by the website, feel free to do that. I prefer using the editor which I normally use. Alright, so we have to complete this function block over here. So the function takes 4 variables, all integers, as inputs, and as we saw before from the question, they will be the starting position of Kangaroo 1, the velocity of Kangaroo 1, the starting position of Kangaroo 2, and the velocity of Kangaroo 2. This function also will return a pointer to character, which, as we know from the question, will be the starting address of a string. It will return either a yes or a no depending on the evaluation. So let's first declare and initialize 2 pointers to character. The variable yes will hold the string yes, and the variable no will hold the string no. Before we can do anything, we need to check if v1 and v2 are equal. If they are, then there's no point in doing any of the calculations, as we will receive a math error. So if v1 is equal to v2, we immediately return a no and our function ends. Next, we declare and initialize a variable n, which we will equate to the formula we derived earlier, x1 minus x2 plus v2 minus v1 whole divided by v2 minus v1. We also declare and initialize another variable, I'll call it m, and equate it with this exact same formula, only this time I'll use a modulus operator instead of the division operator. This will be clear why in the next step. Next, we write another if condition, and inside, as discussed earlier, n should not be negative, which means that n should be greater than 0. Also, m should be equal to 0. And now you probably understand why we use the modulus operator. It is to check if the division yields a whole number or a fraction. If m is equal to 0, that means the division was successful and that we received a proper whole number and not a fraction or decimal. If n is positive and m gives us a 0, then it means that the kangaroos will meet and we return a yes. If either or both of these conditions fail, then the else condition will work and will return a no. So that is all there is to this code. Let's copy this and paste it in the website. I'm going to go ahead and submit. All right, so that was a success. So, all right, guys, I hope my explanation was clear. I have kept a link to the code block I used in the description below. So if I was of any help to you guys, please do consider giving this video a like, as it helps support me and the channel. Also, please consider subscribing if you wish to see more of such videos in the future. So till we meet again, take care. Goodbye.